The U.S. military has released video of yet another Chinese fighter jet harassing and flying dangerously close to a U.S. military plane.
Shocking new details tonight about the condition of the U.S. Air Force tasked with defending your freedom every day.
The United States Air Force is pushing technology to levels that were once thought impossible. Every new development brings a mix of excitement and concern. Weapons that move faster than the speed of sound, artificial intelligence making battlefield decisions, and lasers capable of taking down threats in milliseconds. This is no longer an imagination, it is reality. These advancements are redefining the landscape of warfare and global security. The real question is, where does this lead? If the Air Force is admitting to technology this advanced, what are they keeping classified? How much of what we see is only the tip of the iceberg? One thing is clear, the world is entering a new era of military power, and every nation is watching. The dawn of hypersonic weapons. The world has seen weapons evolve in once unimaginable ways. There was a time when the idea of a missile traveling at 5 times the speed of sound sounded ridiculous. That time is over. Hypersonic weapons are no longer an experiment. They are real, they are fast, and they are changing the way wars will be fought forever. The United States Air Force has spent years perfecting these missiles, and they are not testing them anymore. They are deploying them. The Air-Launched Rapid Response Weapon, ARRW, has already been tested multiple times, proving that hypersonic missiles are not for the future, but the present. These missiles travel over 3,800 miles per hour, making them nearly impossible to intercept. By the time an enemy radar detects one, it is already too late. There is no time to react, no time to defend, and no time to escape. Russia and China have also been racing to develop their hypersonic weapons. Russia has the Avangard, a missile that allegedly reaches speeds of Mach 27. That is over 20,000 miles per hour. China has the DF-17, a missile that combines hypersonic speed with unpredictable flight patterns, making it almost impossible to track. Every major military power is scrambling to master this technology, because whoever controls hypersonic weapons controls the battlefield. The real challenge is not the speed, it is controlling. A missile moving that fast generates extreme heat, which can melt even the toughest materials. Steering something at that speed is a nightmare. Traditional guidance systems struggle to function, and ordinary materials cannot handle the pressure. That is why hypersonic missiles require advanced heat-resistant coatings, specialized avionics, and insane levels of engineering precision. The goal is to make sure the missile hits exactly where it is supposed to. The United States is developing hypersonic bombers, drones, and even space-based weapons that move faster than anything ever built. The X-51 Wave Rider was one of the first successful hypersonic test vehicles, reaching Mach 5 back in 2013. That was over a decade ago. If that was what they revealed then, what are they working on now? The Pentagon has been pouring billions into these projects because speed wins wars. A hypersonic missile does not give the enemy a chance to fight back. It neutralizes threats before they even realize what is happening. This changes everything. Aircraft carriers, missile defense systems, and even underground bunkers all become vulnerable when faced with a weapon that moves at these speeds. The scary part, this is just the beginning. The United States Air Force has admitted to having hypersonic technology, but they are not telling the whole story. What else have they developed behind closed doors? What weapons are still classified? If this is what they are willing to show the public, imagine what they are keeping secret. The race for hypersonic dominance has already begun. The only question now is, who will be the first to master it fully? But hypersonic weapons are just one piece of the puzzle. What happens when you combine unmatched speed with an intelligence that never sleeps, never doubts, and never hesitates? The battlefield is evolving, and the next phase of warfare won't just be fast, it will be smarter than ever. Artificial intelligence in warfare. The military used to have soldiers, tanks, and missiles. Now, the battlefield has a new player, artificial intelligence. The United States Air Force is not only teaching them how to fly jets, but also to think, react, and even make decisions on their own. This is not about replacing human pilots. This is about giving them an unfair advantage. The Air Force has already tested AI-powered fighter jets, and the results are terrifying. In a simulated dogfight, an AI-controlled F-16 outmaneuvered a human pilot in seconds. The AI did not hesitate. second guess, or get tired. It calculated the perfect move every single time. That was just a test. The real question is, how far has this technology gone? AI is running war simulations, analyzing enemy strategies, and even controlling swarms of drones. The Pentagon has been pouring billions into AI programs designed to predict conflicts before they happen. The goal is simple: outthink the enemy before the first shot is fired. The United States is not the only one doing this. China has been aggressively developing AI-powered warfare systems, aiming to create autonomous weapons that do not need human intervention at all. Russia has been experimenting with AI-driven tanks and robotic soldiers. The world is no longer just racing to build the best weapons. It is racing to build the smartest ones. One of the most advanced AI projects the Air Force has revealed is the Skyborg program. The goal is to create AI co-pilots for fighter jets, capable of assisting human pilots in combat. These AI co-pilots will fly alongside real pilots, providing tactical support, analyzing threats, and even taking control when needed. A human brain has limits. AI does not. The military knows this, which is why they are investing so heavily in making sure AI becomes an essential part of future warfare. Drones are also becoming smarter. The United States has already deployed autonomous drones that can operate without human control. These drones can identify targets, adapt to changing battle conditions, and execute missions with precision. They do not get scared. They do not question orders. They do exactly what they are programmed to do. This is both impressive and terrifying. There is a reason why military leaders are obsessed with AI. It makes everything faster. A human pilot takes seconds to react. AI takes milliseconds. A human analyst can take hours to review battlefield data. AI can do it instantly. The more control AI has, the less room there is for human error. That is why the Air Force is not just experimenting with AI. It is integrating it into everything. The biggest concern is not whether AI will work. It already does. The real concern is how much control the military is willing to give it. Once AI becomes powerful enough to make life and death decisions without human oversight, what happens next? If AI decides who lives and who does not, who is really in control of the battlefield? The future of warfare is not about having the biggest guns or the fastest planes. It is about having the smartest systems. AI is changing everything, and the military knows it. The only question left is, who will master it first? The Next Generation Air Dominance (NGAD) program. The United States Air Force is not building another fighter jet. It is building something completely different. The Next Generation Air Dominance (NGAD) program is designed to do one thing: control the skies completely, so that no enemy stands a chance. The air combat rules are being rewritten. NGAD is not a single jet. It is a network of aircraft, drones, and advanced systems that work together. Think of it as an entire fleet operating as one. The centerpiece is a manned stealth fighter, but it will not be flying alone. It will be surrounded by autonomous drones known as Collaborative Combat Aircraft, CCA, that can scout, attack, or defend without risking human lives. These drones will act as wingmen, following the lead of the main jet and reacting instantly to threats. The Air Force is calling this concept distributed lethality, which means spreading combat power across multiple systems instead of relying on a single aircraft. Stealth is the backbone of NGAD. Radar detection has improved dramatically over the years, making it harder for traditional stealth jets to remain invisible. NGAD is designed to counter this. It is expected to have advanced radar-absorbing materials, new heat-masking technology, and electronic warfare systems that can jam enemy sensors. The goal is not to avoid detection, but to manipulate it. Enemy radars will not know what they are looking at. By the time they figure it out, it will be too late. Speed and range are also key. The Air Force has learned from past conflicts that long-range capabilities are essential. The days of launching jets from aircraft carriers and hoping they can reach their targets are over. NGAD is designed to fly farther than anything before it, reducing the need for mid-air refueling. Hypersonic weapons are expected to be part of the package. These weapons travel so fast that they cannot be intercepted by current missile defense systems. Once fired, there is no escape. The Air Force has remained secretive about NGAD's exact capabilities. What is known is that the project is moving fast. A prototype has already flown, and early reports suggest it is exceeding expectations. The United States is not taking any chances. It knows that China and Russia are developing their next-generation fighters. The race for air dominance is in full swing, and no one is backing down. One of the biggest changes with NGAD is the way it is being built. Traditional fighter jets take decades to develop, leading to outdated technology by the time they enter service. NGAD is following a new strategy called the Digital Century Series. This approach uses digital design and rapid prototyping to build and upgrade aircraft much faster. The Air Force wants to introduce new versions every few years, instead of waiting decades for a replacement. This means NGAD will always be ahead of the competition, adapting to new threats as they emerge. Pilots will not be flying NGAD alone. Artificial intelligence will play a major role in assisting with decision-making, navigation, and combat strategies. They are aiming to make pilots more effective while reducing workload. The Air Force understands that wars are not won by technology alone. They are won by the people who use it. NGAD is being designed to give those people every possible advantage. This program is a complete shift in how the Air Force approaches warfare. NGAD is not looking to compete with enemy fighters. It is looking to eliminate them before they even have a chance to fight. Directed energy weapons. The United States military has been working on weapons that do not rely on bullets or explosives. Instead, they use pure energy. This is not a theory. It is happening right now. The Air Force, Navy, and Army are all testing directed energy weapons that can take down drones, missiles, and even aircraft without making a sound. Directed energy weapons, also known as laser weapons, use high-intensity beams to destroy or disable targets. Unlike traditional weapons, they do not run out of ammunition. As long as there is power, they can keep firing. The most advanced versions are mounted on aircraft, ships, and ground vehicles, making them useful in almost any combat situation. The biggest advantage is speed. A laser beam travels at the speed of light, meaning there is no dodging or outrunning it. Once the trigger is pulled, the target is hit instantly. The United States has already deployed several laser systems. The Navy has the ANSEQ-3 laser weapon system, commonly known as LAWS. It has been tested on ships and has successfully taken down drones and small boats. The Army has a system called HEL-TVD, High Energy Laser Tactical Vehicle Demonstrator, designed to protect ground forces from incoming threats. The Air Force is working on SHIELD, Self-Protect High Energy Laser Demonstrator, a system that could be mounted on fighter jets to destroy incoming missiles. These are not prototypes sitting in a lab. They are real weapons being tested in real-world conditions. One of the biggest benefits of directed energy weapons is cost. Traditional missiles cost hundreds of thousands or even millions of dollars per shot. On the other hand, a laser weapon can fire for just a few dollars worth of electricity. This makes them perfect for taking down cheap drone swarms that enemies are starting to use in large numbers. Instead of wasting expensive missiles on low-cost threats, a laser can neutralize them instantly. Power remains one of the biggest challenges. High-energy lasers require a lot of electricity. That is why the military is working on compact power sources that can generate the needed energy without relying on massive generators. Some solutions include advanced batteries and hybrid power systems. The Air Force is also looking into airborne laser systems that could be mounted on refueling planes or other high-altitude aircraft. These would act as mobile laser platforms, ready to strike at any time. Another challenge is weather conditions. Unlike bullets or missiles, laser beams can be affected by rain, fog, or dust in the air. The military is developing adaptive optics and beam control systems to counter these problems. They want these weapons to work in all environments, whether on land, at sea, or in the air. The future of warfare is changing fast. Directed energy weapons are not an alternative to traditional weapons. They are becoming a necessity. Enemies are using faster, more unpredictable attacks, and defenses need to keep up. A missile defense system that can only fire a limited number of shots is not enough anymore. The military needs weapons that are fast, efficient, and never run out. The United States is not alone in this race. China and Russia are also working on their laser weapons. Whoever perfects this technology first will have a massive advantage. The Pentagon is pushing hard to make sure that advantage belongs to the United States. As laser weapons heat up the battlefield, another game-changing technology is taking flight, one that will redefine what it means to dominate the skies. Speed, power, and precision will no longer be dictated by traditional engines, but by something much smarter and more adaptable. With Advent, aircraft will soar into a future where performance is limited only by imagination. Adaptive Versatile Engine Technology, Advent. Engine technology has always been at the heart of military aviation. Think about it. Without powerful engines, you do not have speed, agility, or the ability to outmaneuver threats. The Adaptive Versatile Engine Technology, Advent system, is here to turn that traditional thinking upside down with engines that can do things we once only dreamed about. At the core of Advent lies the idea of adaptability. Imagine an engine that can adjust to different flight conditions, making aircraft faster, more fuel efficient, and far more capable than ever before. With Advent, military jets will be able to change their power settings on the fly, depending on the mission. It is like giving an aircraft a brain to think about how to perform at its absolute best in every situation, whether it is climbing at high altitudes, accelerating rapidly, or performing complex maneuvers. The beauty of Advent is that it can drastically increase an aircraft's performance thanks to its adaptive fan and variable nozzle. This means the engine can easily respond to dynamic environments such as high-speed flight, sharp turns, and altitude changes. For example, when the plane needs more power for high-speed maneuvers, the engine fan adjusts to take in more air. In contrast, when the aircraft is cruising at lower speeds, the nozzle closes up to conserve fuel. It is almost like having a superpower that only reveals itself when necessary. The military has long been dealing with a constant balancing act. On the one hand, fighters need to be fast and agile, and on the other hand, they need to be fuel efficient for long missions. Advent gives the military both. It reduces fuel consumption during cruising phases, but when it is time for a high-speed chase, Advent makes sure the engine is ready to roar. In essence, the engine adapts to what the mission demands in real time. One example of where Advent technology has been tested is on the X-45A UCAV, Unmanned Combat Air Vehicle. Engineers strapped this engine tech to an unmanned prototype, and the results were impressive. They saw better thrust-to-weight ratios, improved fuel efficiency, and much better performance in all phases of flight. This opens up huge possibilities for next-gen fighter jets that need both versatility and reliability. What makes Advent truly special, however, is its potential to be integrated into next-generation aircraft, such as the F-35 or the upcoming Next Generation Air Dominance (NGAD) program. These advanced aircraft could benefit from an engine that learns to adapt to each unique challenge in the air, making them far more flexible in real-world combat situations. The impact goes beyond the performance boosts too. By reducing reliance on traditional jet engines and maximizing power efficiency, the military can save valuable fuel and extend mission range, something that will be critical in future combat scenarios where every drop of fuel counts. The future of Advent technology goes hand in hand with emerging innovations in AI and machine learning. With the ability to predict and respond to various mission parameters in real time, the engine could adjust on the fly based on data gathered from sensors, AI algorithms, and past performance. These systems will be able to think ahead and optimize engine performance for maximum success. Some experts argue that we may still be a few years away from widespread implementation. Though the technology is showing promise, a few kinks still need to be worked out, especially around durability and maintaining performance under extreme conditions. Engineers are working hard to make sure the adaptive system does not wear out prematurely, which could present issues when lives are at stake. However, Advent is on its way to making fighter jets much more capable, versatile, and mission-ready in the skies. The military is preparing for a future where adaptability is key. The battle for air superiority is no longer just about who has the fastest jet, it is about who has the smartest engine. If Advent becomes the standard, we may see the skies ruled by aircraft that can adapt in real time, making them untouchable by traditional enemies. With Advent at their core, the next generation of fighters will perform with an agility and efficiency we have never seen before. Space-based missile defense initiatives. The idea of space-based missile defense is not new, but it has become more urgent as modern threats evolve. Traditional missile defense systems were designed to counter predictable ballistic missiles, but today's hypersonic weapons move at speeds exceeding Mach 5, changing course mid-flight and making interception much harder. This shift has pushed the United States to look beyond ground and sea-based defenses, turning its attention to space. The military is working on an advanced satellite network capable of tracking these threats in real time, using infrared sensors and AI-powered analytics to detect missile launches the moment they happen. Unlike ground-based radars that struggle with tracking hypersonic weapons, space-based systems offer a broader, unobstructed view of the battlefield. The idea is not entirely new. In the 1980s, the Strategic Defense Initiative, SDI, nicknamed Star Wars, aimed to develop space-based interceptors but was abandoned due to technological and financial limitations. Now, with improved satellite capabilities and more powerful tracking sensors, the concept is back. The Pentagon is funding programs like the Hypersonic and Ballistic Tracking Space Sensor, HBTSS, to create a layered missile defense system. In 2023, the United States successfully launched prototype satellites that track high-speed threats in low Earth orbit, marking a major step toward real-time missile defense. The long-term goal is to integrate these satellites with land, air, and sea-based systems, creating a defense network that can intercept threats before they reach their targets. However, deploying weapons in space comes with serious challenges. Space is a harsh environment with extreme temperatures, radiation, and debris that could damage equipment. Maintenance is another issue. Once a satellite is launched, it is nearly impossible to repair. Then there is the cost. Developing, launching, and maintaining a space-based defense network requires billions of dollars, raising concerns about sustainability. But the biggest issue is geopolitical. The 1967 Outer Space Treaty bans weapons of mass destruction in space, but there is no clear rule against missile defense systems. Still, countries like China and Russia see this as a step toward weaponizing space and have already warned that such a move could trigger a new arms race. If the United States advances its space-based defense, other nations will likely respond with their satellite weapons, increasing tensions. Despite these challenges, the push for space-based missile defense is accelerating. The Pentagon sees it as a necessary step to stay ahead of emerging threats, and with recent advancements in satellite technology, what was once impossible is now within reach. The future of missile defense may not be on land, in the air, or at sea. It may be in space, where the race to control the battlefield has already begun. Advanced materials and manufacturing. The world of advanced materials and manufacturing is changing fast, and the race to build stronger, lighter, and more efficient technology is on. Countries investing in these breakthroughs are improving their industries and shaping the future of defense, aerospace, and infrastructure. The focus is on creating materials that can handle extreme conditions, enhance performance, and even save lives. Take hypersonic weapons, for example. These missiles travel at speeds greater than Mach 5, generating intense heat that can melt conventional metals. Standard manufacturing techniques cannot produce materials that can withstand such conditions, which is why researchers are turning to ultra-high temperature ceramics and carbon-carbon composites. These materials are designed to resist extreme heat while remaining lightweight, making them ideal for hypersonic flight. The development of these materials is for defense, not offense. If a country can create materials that make weapons faster and stronger, others need to find ways to counter them with equally advanced shielding and armor. Manufacturing is evolving as well. Traditional assembly lines are being replaced by automation, AI-driven quality control, and 3D printing, which allows for faster, more precise production. The aerospace and defense industries are using additive manufacturing to produce complex parts that were previously impossible to create with conventional methods. This technology is making aircraft and spacecraft more efficient while reducing waste and costs. The ability to print lightweight, high-strength components is revolutionizing everything from fighter jets to next-generation satellites. Nanotechnology is also playing a major role in material science. Scientists are developing nanomaterials that can improve durability, conductivity, and even self-heal. Imagine a jet that can repair minor cracks in its wings during flight, or a body armor that becomes stronger on impact. These innovations are not just theoretical. Research is already producing materials that change their properties based on environmental conditions. This could lead to next-generation military gear that adapts to different threats in real time. While these advancements are exciting, they come with challenges. Developing new materials is expensive and time-consuming, and scaling up production is not always easy. There is also the issue of supply chains. Many of the rare elements needed for these materials are controlled by a few countries, creating competition for resources. Governments are investing heavily to secure access to critical minerals and to develop domestic production capabilities. This is a high-stakes game, and those who lead in advanced materials will have an edge in military and industrial dominance. The future of advanced materials and manufacturing is already here. From hypersonic weapons to self-repairing materials, the technology being developed today will define the next era of defense and industry. It is no longer just about who has the best weapons or the fastest planes. The real competition is in the materials that make them possible. But as nations race to outpace each other with these groundbreaking technologies, there's a dark side lurking beneath the surface. When does innovation stop being a tool for defense and start becoming a weapon of control? The stakes are not only about who wins the arms race, but at what cost to humanity. Ethical and strategic implications. The development of advanced military technologies raises a crucial question. At what cost does progress come? The rapid advancements in weapons, surveillance systems, and even space-based defense technologies are not only reshaping global power dynamics, but also introducing serious ethical and strategic challenges. These innovations, which often promise greater security, can easily cross into realms that challenge moral boundaries and human rights. For example, autonomous weapons systems can make life or death decisions without human intervention, posing profound questions about accountability and the potential for misuse. The idea of machines deciding who lives and dies is unsettling, to say the least, especially when you consider how such technologies can be employed in conflicts where rules of engagement are blurry. Autonomous weapons are not the only ethical concern. The rise of surveillance technologies, such as drones and satellite networks, also presents a moral dilemma. While they may be useful in tracking military targets or ensuring national security, these tools can easily be turned on civilians, eroding privacy and personal freedoms. Governments and corporations are already using these systems to monitor large populations, often with minimal oversight. The question then becomes, where do we draw the line between ensuring safety and infringing on civil liberties? The use of advanced surveillance tools has the potential to create a society where everyone is constantly watched, making the balance between freedom and security harder to achieve. These ethical concerns tie directly into the strategic implications that come with technological innovation in the military sector. Countries that have access to cutting-edge technologies gain a significant strategic advantage. Whether it is advanced materials, AI-driven defense systems, or space-based missile defense, the race for technological supremacy can shift the balance of power. Nations without access to these innovations may find themselves at a severe disadvantage, potentially creating a new form of global inequality. For example, smaller or developing countries that cannot afford these advanced technologies might struggle to defend their sovereignty, creating vulnerabilities that could be exploited by more technologically advanced nations. However, the strategic implications of these technologies are not about power imbalances. There is also the risk of escalation. The pursuit of more advanced military capabilities can lead to an arms race, where countries continuously develop more sophisticated weapons in an attempt to stay ahead of their rivals. This cycle could drive nations to prioritize military spending over other essential sectors, such as education or healthcare. The enormous financial burden of this arms race is not an economic issue, it is a question of priorities. Should nations be investing in advanced weaponry, or should they focus on addressing issues like poverty, climate change, or global health crises? At the same time, these technologies can foster greater international cooperation. Countries that have access to these innovations often collaborate, sharing their expertise and resources in efforts to ensure mutual security. The development of advanced defense systems could foster partnerships that transcend geopolitical rivalries, leading to a more stable and interconnected world. However, these benefits will depend on how the technologies are implemented and regulated. The future of warfare and global security will undoubtedly hinge on how we navigate these ethical and strategic challenges. The technologies we develop today will shape the world tomorrow, but it is up to us to decide whether those developments will lead to a safer, more equitable future, or one defined by inequality, surveillance, and unchecked militarization? We must not only ask whether something can be done, but whether it should be done. The United States Air Force's pursuit of advanced technologies underscores a commitment to maintaining national security and technological superiority. As these developments unfold, it is crucial to stay informed and engaged in the discussions they provoke. Be sure to check out our next video on the future of unmanned aerial systems.